startup here in India from Bangalore. So in this session, I'll be primarily walking through this two primary technology that's kind of on the hot topic right now, A2A, agent-to-agent protocol, and the MCP itself. So let's get started on that. Right, like before even like we will be covering the major aspect of what A2A is, MCP is, and when to use what, why there are two different protocols, and how is this actually helping in the world of LLM and generative AI. So before starting to that, let's discuss like why do we need protocol in the first place itself, right? So let's imagine like we want to build a futuristic company where everything is automated. Like we use robotic arms and we use sensors and like there's completely automation there. Like it's super cool and it's like super futuristic. But deep dive into what kind of information at each of these component would go through, like in terms of electronic automation, there is the MOBDAP protocol, and then in case of sensors, it's fully MQTT followed, and in case of robotic involvement, there is like the complete instruction from um, the 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 programmer itself to come in. Like each individually performs well, but they don't communicate with each other across. So, and in this particular session, we'll also be looking into the hospital case primarily. So, when I extend to hospital use case, like let's say there's a patient who's coming in because of a heart problem to get admitted or to get treated, it might be an emergency, right? So, he might have the hospital might have the database. Managed and controlled by a certain company, and the equipments might be from certain international company, and the pacemaker itself would have been like controlled and monitored from certain firm. So all of these are like individual components, and like when a heart patient comes into the hospital, like a cardiologist might be the right person to talk, but unfortunately due to emergency there might be only a person from pharmaceutical department would only be available. Now each of them are expert in their own domain, both in this factory and in the hospital setup, but like they don't communicate together, unless and until they can establish a common ground to enable that communication, the intelligence goes into waste. Say it is the same case for LLMs as well. So the unification is basically bought by protocol takes care of sending the data, formatting it, and make sure that it is interpreted well as well. Like in our web based world, like we have client application and the server based application, and most of them gets communicated through REST API in paired with HTTP or HTTPS protocol. And what is this REST API? It is like simple get, post, put, and delete endpoint, and that's how we establish communication. So if this is not there, the entire system is chaotic and the intelligence goes into waste. So same thing came the same problem is like getting encountered in the world of LLMs as well. So LLMs are large language models, and they are generative in nature. Generative as in like they kind of generate one word another after another. So that's basically what generative AI is. And like each of these LLMs are from different vendors. Like OpenAI, they release a family of GPT models, which follows a specific architecture and specific method of training and fine tuning, versus what Anthropic does, versus what Mistral does, and so on. So there are like different LLM vendors with different set of prompting, fine tuning, or architecture that gets employed. And these LLMs also gets pre-trained or get trained on a large corpus of knowledge from the internet itself. At the end of the day, we use LLM for a specific use cases like summary, or let's say getting a structured data out of a particular document and so on, right? Now usually what we do is now this LLM, it tends to hallucinate because it have seen a lot of data from the internet itself, on its pre-training phases. So in order for us to hallucinate less, there came a concept of RAG, which is nothing but retrieval augment generation. So what it does is it basically the LLM via prompt, we retrieve a relevant chunk, either the embedding or the within the DB itself, and then we get the relevant information. So that tends to um, that tend, that has been a primary way of mitigating hallucinations itself. So one could be that, and another could be like set of tools and function calls. Like an LLM can have an access to a set of APIs, and it could get information from that. So that way we ground, um, we kind of set up a soft boundary on how the LLM want to respond. So that's like primarily the use case, like in the industry or in any pet projects you guys work. So that's like typical architecture, right? Now this is okay if I have one LLM and if I have one use case, but that is not the ideal scenario. Like let's take in the case of um, chatbots itself, right? It should like one LLM should take care of, would be there to dedicatedly um, take care of like rephrasing the way it should respond based upon the sentiment or the intent, and the other would make sure that it calls the or fetches the relevant documents and then grounds it input to that. So this leads to like lot of LLMs with specific use cases. So we grow in terms of LLM applications itself, like around n numbers. And since like generative AI is like dynamic in nature, and we are still figuring out what is the right use case, scalability and maintainability, it becomes a huge issue, right? So let's say like I develop a particular LLM application that speaks with a particular RAG library, and assume that these both are like kind of external party. So whenever these external party changes or updates the way they communicate the endpoints, I also have to make sure that I have to update in the LLM application. So that would be good if we are talking about only one, but that's not feasible at a large scale. So in order to mitigate that, um, MCP came into picture. Like it was released by Anthropic. Uh, it's basically the model context protocol. So we all knew USB, right? It's used to connect different hardwares and enable the communication between them. Without MCP, it would be like the olden days computer systems, right? So where we used to have a dedicated hardware in different in only one environment, but as use cases grew, like the logistic team need their own supply chain management, or the finance team needed their own ERP, uh, and we need to develop different CRMs for different business use case. Like the the monolithic architecture got broken down into different use cases, but like the only way to communicate there was like to manually copy the data and then store it in email and then change it. So that is not feasible, and it's like it consumes a lot of human labors. So that's where protocol shows its leverage on the way we communicate. So what MCP basically does is it establishes a certain rules similar to how we have REST API with HTTP, and then it enables the integration. So what like in imagine in this particular case, what happens is like we'll have our host, MCP host. It might be your VS Code or Cloud Desktop or a Cursor, and you will define your own MCP client within. Basically, it's like a set of interfaces that you write in order to communicate with the external MCP servers. So once you define that, like all you have to do is instead of integrating with the tool itself, the tool will have its own MCP. Uh, okay, yeah. Basically, we will establish the communication between that. The beauty part of this is the MCP provided by the third party tools or a prompt manager or the DB itself. They are like self managed. You don't have to worry about the integration between the LLM application and the LLM applications. The client MCP versus the server MCP. It's kind of self-managed and self-evolving. So that eliminates the overhead of us not us when we talk about LLM applications in the scale itself. So these are like few key capabilities, and majorly we use these client protocols when we need to integrate with tools, function calling, or accessing a DB, or like a prompt, getting a prompt template itself, right? So everything is taken care. Like it will be a standardized protocol, so we could um, enhance the unification of the LLM application with the external knowledge itself. So that's like the MCP and all. So this is great. Let's in case of like hospital cases, it would be like attaching to the relevant databases, or a tool or a third party service to get certain informations. So that would be like patient database or medical equipment or the hospital information itself. So that wraps up the idea of MCP. Now if we okay so that's like that's good. Now let's say this particular, we could imagine this particular sector as one agent managing only one particular use case. Like if you take for an example of a travel planner, there can be one LLM application that has the access of flight databases, or it has the API service authentication for like airlines like JetBlue or American Airlines and so on. So it could take care of booking. Next, like there is another aspect of hotel managements in case of travel bookings itself, right? So we would again build another agent with the similar, with the relevant tools and access. So we will have such number of agents for specific use cases. Now, how do we establish communication between these agents itself? That's when A2A protocols come into picture, and that's like agent to agent protocol established by Google itself. So, earlier it should be like we need to pass in the entire context of the agent versus what the agent does and how does it communicate. All those overhead are like simplified with this agent to agent protocol, right? In this case, with respect to hospital scenario, you could imagine these as agents as the specialists in their own department, like cardiology AI department, at the pharmaceutical department, and a kind of a protocol or a communication platform that's established between these specialized platform, right? um, yeah, so like Google has also like released a library which is like a very simplified platform, and it's like super powered with the Vertex AI and the Gemini and the Flash model. Like it supports both voice and chat, and it's super easy to build. But it's not limited to that. We could integrate with the other vendors as well. And we have like they have in-house agentic frameworks. Like they have a garden where they have like few of the agents already enabled. So if you see this particular demo, like a person is attaching a PDF, which basically is the knowledge of that. And then if you see here, we could see like a- how the thing okay, how each agent comes into place. It's not only that the agent is in play, it is also like what particular agents gets kicked in for what, for that particular query. So those kind of nuances are like kind of established, and it's very well um, very well mm, very well exposed or explained in the agent to agent protocol itself. We don't need to worry. All we have to do is like build a specific agent, and then we need to make them communicate. That's all. So that's the holistic idea of how A2A and then MCP comes into picture. And yeah. Hmm. Now, like let's like focus into one particular use case, which is the hospital use case itself, right? So we know like when a heart patient or somebody comes in, we knew that the equipments that the patient has within himself versus what the hospital provides and the DB provider, everything are like third party people, right? Now these are like split into different places, and in order to unify that, we will have the MCP and A2A coming into play here. Right now, the uh, now when like let's say like when the heart monitor itself like, is made by like a third party vendor like Philips, and the blood pressure monitor is like made by GE, and the X-ray is from like Abbott kind of places. Like when these guys establish their own MCP servers, all we have to do is build a MCP client and then establish that communication with them, so that we will have the knowledge of what is happening, and we'll have one unified place that we could make sense of all of the information. Else it will be like one information missed when it could have been actually critically helpful over there, right? um, so in this case, we will have these kind of data system, the electronic health records, vital sign monitors, the laboratory systems itself, imaging like X-rays, and the pharmaceutical databases, like including the patient himself. So this would be where MCP comes into play. So you could imagine where. So if you have the question on where to employ MCP versus where to employ agents, it's basically when you have tools and service calls and the database access, MCP comes into play. And when there's a specialized action, and there are different agents like the specialized compute, and if you want to establish communication between them, then A2A comes into pictures. So like here AI agents can be like, one could be like an emergency diagnostic AI helper, and one can focus on only on cardiology, another on radiology. So when I say radiology, it basically will have all the database dedicated to radiology and the patient attached, like embedded into it, so that it makes the agent will be specialized only in the radiology kind of department. Now, like let's look into a small demonstration of the same. Mm, like, hmm. So we'll have these data integration set up, the patient's vital set synchronization, the medical records, and the lab results if any exist. And in case of agent to agent, we will have the cross department, as in like as we saw, right, the pharmaceutical and department integrated with the cardiology department, and so on. Like we will have all the cross department network set up, and so that they could have better planning, better consultation network, and so on. If you see here, right, so here this would be like what a higher overview on what MCP would have the access with the EHR system, the vital monitor system, the lab reports, and the X-ray reports and everything. Um, what MCP will do is, like if you see here, we will basically establish the connectors or the interfaces to this particular databases or the service, and that's all what MCP does, right? So if you see, it connects to the database, and then it's all the CRUD operations that we basically do. And if you recall this diagram, so basically we are establishing this particular uh, communications through MCP. And if you see, it will start connecting to the data source, retrieve the relevant patient's context, and then it will start generating the diagnostic reports. Now, this is good. Like we will have the baseline information of a patient who's coming into the hospital system itself. Now, we need more rich insights. Like this data itself wouldn't be enough. We would need a specialized opinion on it, like the cardiologist opinion or the pharmaceutical opinions, right? So for that, we will have the agent to agent collaboration established for that planning and consultation network. So we will have each of this agent specialized for each of the department. And then there we will build a coordination platform using the A2A protocol. Like if you see here, unlike besides like we connect to the data source, we will also like where is it? Oh, sorry, I didn't switch. Hmm. So besides like only retrieving the data, besides the CRUD operation, we will also start collaborating with each of the department, and we'll start analyzing what is happening. So this is where the actual actions take into place. Like MCP, if it powers the individual doctors, like A2A agent kind of superpowers the cross communications between different departments. Like pharmaceutical department might have insights that the cardiologist may not have at all. So we will start uh, correlating those kinds of insights across the departments itself. So, again, like all of these are like to build all of this, it takes very minimal effort, and the it is more of an industrial use case wherein the maintainability and the scalability is kind of taken care. So if you see, like they will start into actual reviewing rather than uh, just retrieving the database. It's like beyond going the data and start the actual consultation itself. So here we will have a very quicker insight, and we could also avoid any um, gap that had exist earlier because of the lack of coordination between different departments, and we could enhance the treatment of the patients who's coming better in case of like peak hours in the hospital use case of scenario. Now this could extend to lot of real life cases like logistics, supply management, or the ERP reports or the CRM managements and so on. So this is like just getting started, and this would be super cool because as the days passes, there's like lot of LLMs that's getting released with lot of tooling capabilities. And like when A2A got released, it also got released with like around 40 supported platforms which already established this particular protocol. So this enhances the unification and improves the intelligence of the system itself. Like the use case is like infinite when we integrate when we empower A2A plus MCP together itself. So yeah, so when to use what, to summarize it, like we need MCP when we need a secure structured data access. Again, authorization, everything is like taken care uh, already. And yeah, so when you need database toolings or prompt templating, we will basically opt for MCP. And when you need a specialized agent use cases, you'll opt for A2A. And also, with regards to workflows, we could also configure, orchestrate on how we want this agent to communicate. If we need it to be sequential or if we need to be parallel, we have that option of designing the workflow of this agent itself. So that will basically enable the cross organizational and would lead to a better planning of the entire platform itself. So that's the thing. So usually, whenever we build any use case, even in case of the hospital, as we saw, we will opt for an hybrid approach in order to like improve the quality of the system itself. Um, so that's it. Like it's the capabilities of this like of MCP and A2A is like limitless. Yeah. So if you see here, we could see like based upon the use case that we saw, we could classify which department to be designed as what, and we could just implement them. And also we have like the community support, like it's like an actively growing field, so it's easy to integrate. And like most of the current industries and companies have started integrating um, and publishing their own MCP servers and stuff. Like you could You could build your own as well and publish it. And there's like a lot of open source one that you could access like in your VS Code itself. So that's the thing. And so the main thing is like we don't have to worry about the maintainability. It won't be a chaos anymore. And it's like easily scalable. You could build a standardized application with this. Yeah, so that's pretty much just like there are like a lot of open source libraries, SDKs built around. Um, like you guys could check and work it out, and there's also like tutorials available which requires like very minimal resources. Like you could just launch your collab and then replicate the same as well. So that's pretty much from my side with regards to these. Yeah, is there any questions?
Just one question. Last question. Can we get this example source code? So I told that I'll asking you. So if it's possible, please can you share this source code with attendees?
Yeah, sure. I'll do that.
Okay, perfect. And any other questions? So from my side, because since it was so clear, so short, and so dive deeper into such amazing topic.
All right.
So if you have any questions, feel free to share in our chat. For now, you prepare, yes, how to share this source code with our attendees.
Yeah, I'll share
Okay,
that.
okay.
Yeah.
So until we haven't any questions, so we can move to our other speaker. Yes, 1 second. I'll stop recording this talk.